Read this question in detail. You will find an annular disc is placed on horizontal surface with a friction coefficient mu. At some point, an impulse is applied, a J naught impulse at a height of h is applied, and the center of the disc, the height h is above the center of the disc. Now, disc rolls without slipping along the x-axis. That's all is the question. Now, see this. This impulse, which we generally understand as a change in momentum, the impulse vector as the change in momentum. That means if the mass of this particular disk does not change, which is given as m, there must be a change in its velocity. Now, if this disk initially is not moving, is not initially in motion, then the velocity that is imparted to its center of mass v is the value of change, and therefore this is equal to m into v, because u is equal to 0 for the disk. The disk was initially not moving. Now, therefore, the impulse converts to a pure momentum value later on after applying that impulse. Applied at a height h, then it can convert to the angular momentum. Angular momentum will be equal to, therefore, m into v into h. Now, this particular v, when this impulse is applied at a height h, the disk starts rolling. It starts rotating. Let's say the angular velocity that it attains is omega. Now, if it attains an angular velocity of omega, then the angular momentum that it can attain is equal to I into omega. Now, moment of inertia of this disk, if it is an annular disk, will be equal to m by 2 into a square plus b square. Let us say this is the situation where you are applying the angular momentum. Now, let's say the impulse application height h as is given in this question. If you read carefully, the disk has a radius a and b, has a friction surface has a friction coefficient mu, and impulse is applied, and then suddenly this particular data, if h equal to hm, unsettles your understanding about the question. Let's come to this point. If h equal to hm, that is the point of application of the impulse can be changed as hm. Let's say it can be brought in here. If this height can be treated as hm, then the impulse can be applied at this point, but the value of the impulse would remain the same, and therefore we can say that this can be an hm, where this v is equal to r omega, v equal to r omega if it is applied. Then if this is the omega attained and if this is the height of application of the impulse initially, then it can be equal to omega h. Therefore, m omega h is basically the momentum into hm becomes the angular momentum, and which is equal to, let's say, m by 2 into a square plus b square into omega. This is the basic equation with which we can solve the question. Now, let us go to this question and start solving the options one by one. If mu is not equal to 0, that means if there is a friction, it is definitely going to have a rolling motion, pure rolling motion. Now, if a tends to 0, this becomes m by 2 b square. So for option A, if we start solving this question for option A, then we will write that m omega into h. Now, let's say A tends to 0, means this will become 0 and it will be m by 2 b square. But what about this h? Let's say we apply the maximum impulse value. That is, if h becomes equal to b, if this h becomes equal to b, I am using this condition for this is for J naught maximum. Let's say I write this as J naught max. If I apply, then what will happen is m omega into b. Okay, all right, I'll solve it here, right here, with h equal to b condition applied. I'm saying again. So therefore, m omega b into hm is going to be equal to m by 2 into b square into omega. Remove m omega from the situation, m omega b from the situation, and you get hm is equal to m omega b removed, you get a b by 2 solution for hm. You get a b by 2 solution for hm. I'm so sorry. I'll solve it again, just a moment. What I'm saying is m omega b into hm. If I solve, if you remove m omega b, then hm is going to be equal to m omega b removed brings it b by 2. Now this is where your option A holds correct. You see this. And this is under the condition that h equal to b, that is height of application of the impulse is maximized and maximum impulse is applied, and then hm is the height of you can say observation of the impulse, and then hm value comes up as b by 2. Basically you can measure the impulse with a certain height which is h equal to b and apply it at a certain different height. H is the height at which it is measured, hm is the height at which it is applied. So hm is the height at which you can apply. At this height, if you apply, then you are going to get the pure rolling motion as is needed, rolls without slipping. And therefore, option A is definitely correct. Now again, for mu not equal to 0, that is if there is a friction, and A tends to B, that means this is going to become a thin ring. A tends to B means this is the case of a ring. And A tends to 0 means this is the case of a disc. And for a ring, the moment of inertia is going to be simply mr square. Now, if A tends to B, that means this is going to be mr square, and hence the hm value. Now, let us calculate again for option B. So, again for h equal to B, if I write m omega b, m omega b is the j value, j naught value, and hm is the height of application of this particular impulse. And then this becomes, if A tends to B, then we have mb square into omega as I omega value. Now you remove m omega b again, and you have hm is equal to m omega b removed is equal to b. Now that means your option B holds correct, and therefore this is a correct option. Now for h equal to hm, initial angular velocity omega does not depend on the inner radius A. This is a point blank correct statement. Now for mu equal to 0, for mu equal to 0 and h equal to 0, that means you are talking about a frictionless surface, a smooth surface, and h equal to 0 means you are applying the impulse at the center. Now if the impulse is applied at the center, think on this again. If the impulse is applied at this point, at the center of the disc, the wheel always slides without rolling. It cannot, because the friction is a basic necessity. The friction is a basic necessity to create this torque or angular momentum. And this goes straight without sliding and slides without rolling. And that creates a particular, you can say, static translational motion. For option D is correct. Thank you for your patience. See you in the next question.